Today's video is about Lewis basic strength of ammonia and its derivatives. First of all, let us know what is a Lewis base. A Lewis base is a substance that has an extra pair of electrons. That means one or two or three lone pair of electrons which are present on the central atom. Such molecules can act as Lewis bases, which act as an electron pair donor. We call them as electron pair donors. So, the tendency to donate a lone pair of electrons by the molecule is said to be Lewis basic strength, and the substance is called as a Lewis base. So, let us consider first ammonia, which is NH3. Nitrogen is the central atom. Here nitrogen has one lone pair of electron. So, when we elaborate the structure of ammonia, nitrogen is at the center, hydrogens are bonded to it, and nitrogen contain one lone pair of electron. Now in this molecule, hydrogen, three hydrogens are bonded to one nitrogen. So bonded elements are nitrogens. So these are bonded elements, and nitrogen is the central atom. Nitrogen is said to be the central atom. So, compared to hydrogen, nitrogen is a more electronegative element. So, what is the importance of electronegativity? The tendency to pull electrons by an atom. If it is high, its electronegativity is said to be more. So, since nitrogen is more electronegative than hydrogen, electrons will be pulled towards the nitrogen from all the three bond pairs. So from all three sides, bonded pair of electrons are more concentrated towards the nitrogen. So nitrogen will have more partial negative charge on it, and nitrogen being the small atom, it cannot hold such high negative charge. So it will try to donate the lone pair of electrons to the other element or a molecule which is in need of electrons. So in ammonia, nitrogen atom acts as a very good electron pair donor. So hence ammonia molecule is a strong Lewis base. It's a strong Lewis base. Consider the second compound, that is NH2, which is called hydrazine. This is obtained by removing one of the hydrogens from ammonia and replacing it with NH2 group. So then we get this compound NH2NH2, or you can also write it as N2H4, which is called hydrazine. Hydrazine is the name of this compound. So in this molecule, if you look at the structure, nitrogen is still the central atom. Two hydrogens are there connected to nitrogen, and in the place of one of the hydrogens, we have now NH2 group. So this NH2 group nitrogen also has a lone pair of electrons. So here these two are the bonded electrons, bonded atoms, and in place of one of the hydrogens we have NH2 group. So here N is connected to NH2. N is connected to NH2. So here both the nitrogens are equally electronegative. Both the nitrogens have one lone pair electrons on them, and both are equally electronegative. So the electrons will now be at equal distance from each other. The bonded pair of electrons will be at equal distance from each other. So the dipole moment or any polarity that exists between these two will be cancelled out with each other. So because of this, the electron density on the central nitrogen atom will decrease. Electron density decreases, unlike in the case of ammonia. So this results in the formation of decrease in the tendency to donate a lone pair of electron. Electron pair donating capacity also decreases. Hence, it is a less strong Lewis base. So the third compound, that is NH2OH, which is the hydroxylamine. Hydroxylamine is the name of the compound. So here nitrogen is still the central atom. Two bonded atoms are hydrogens and the other bonded molecule is OH. But here O is directly connected to nitrogen. So first two are the same bonded atom similar to that of the remaining two compounds, but we need to look at the oxygen here. So nitrogen is directly connected to oxygen. Nitrogen is the second most electronegative element, third most electronegative element in the whole periodic table, whereas oxygen is the second most electronegative element in the periodic table. So nitrogen electronegativity is less compared to oxygen. So the electron density between nitrogen and oxygen will be more directed towards the oxygen. That means oxygen is pulling the electrons away from nitrogen. So nitrogen will get partially positive charge, oxygen will get partially negative charge. Since nitrogen is getting positive charge, that means it itself becoming less electron dense or more electropositive. In such case, it will not be in a position to give electrons to the electron deficient molecule. So hence the electron density decreases, the tendency to donate electrons also decreases, and this becomes a weak Lewis base. This becomes a weak Lewis base, and hence the order will be ammonia being a strong Lewis base. Second strong will be the hydrazine N2H4, and third strong will be NH2OH. This is the Lewis base strength among the ammonia and its derivatives.